Hi friends, today our topic is deck slab design. Deck slab design. Selecting the space, add beam mode. In this we'll use here also grid mode by using front mode, and here just grid is editing for on the x-axis of 5 for 4. Okay and okay. Let us assume that our span of the deck will be 20 meters and the height of the deck will be 10 meters. So first starting from 20, 10 point, selecting a beam in this, selecting by this we have selected the members and nodes. Select all the members and use the transitional repeat along z direction for 5 meters up to the 5 steps. That means total is 25 meters, the length of the span. That means deck will be the 25 meters. Now you can observe the link up and open base. This is our deck slab geometry design. Now moving to the general, in this defining two properties, that is circular property with 0.6 meters for the columns, and for the rectangles 0.35. will use square beams for the deck slab design. And use the thickness of the slab will be 0.45 meters. Assigning the thickness to the assigning view mode by using plate cursor. Before assigning the thickness, you have to generate the surface plate. So by using geometrical generate mesh, we will generate the plate in the quadrilateral meshing mode. Along x direction will take 20 divisions. Okay, this is our page. Now we are assigning the plate thickness. Now for the circular column, go to the select and select beams parallel to y and assign the beams. Then select the rectangle by selecting beams parallel to x and z. Now you can see in the 3D render view either our deck slab is adequate or not. I am zooming for you to clearly observe the deck slab. Okay, you can see here how the deck slab is there. Now we'll fix the supports. That means creating fixed supports and assigning this support by using front view to the bottom of the columns to fix the structure. Then moving to the load case details. For the deck slab, we are defining the definitions. That means we are designing for both seismic loading and dead loading. So before that we have to go to load case details. In the primary case, we have to take the seismic loading as a first step, seismic loading, and the second step we will use dead load. Okay, and then go to the definitions and use sesmic loading as IS 1893, 2002 and 2005. Now close, and here add the sesmic loading with the factor, self weight factor as -1, joint weight factor as -70 kilonewton. This will be assigned to the view defaultly, and this will be assigned to the view for the all nodes of the deck slab and the columns. Okay, we are assuming that for the nodes there will be a 70 kilonewton of force in the advance only. Now go to the load case details. In there add the self weight as -1 and assign to the view. Then add the dead load with the -1 factor and again assign to the self weight as -1. Then analysis and print all the options and close and perform a single analysis. There is one error. Let me see that. Let's move to the general. In the general loads and definitions, here the parameters are mixing, so we have to generate the parameters, changing and giving, again doing analysis. Here you can observe that 0 errors, 0 warnings and 0 nodes. Now select in the mode as bridge deck preprocessor. We are designing for deck slab, so now select the slab in this, and in the top option select deck. In that create deck, give the name as deck slab 1. Okay, now go to the deck and select the define roadway. We'll select the new roadway in the custom mode. We'll select as a left line as the curve. We'll leave in the left side the 2.5 meters. Okay, and the right and the copying continuously to the 1 month meter. Each spacing will be 3.3 meters. Okay, or else you can select that as XS 2.5 and the Z will be the 20 meters completely. Length will be the 20 meters with 90-degree orientation. Our span is 25 meters, so we are selecting 25 meters. The width of the road will be 3.5. okay, and this is copying at the right side also. we are going to curve but right side. Here in this again minus 2.5 and the width will be 3.5 and the length will be again 25 meters. The direction will be 90. This will be minus 17. This will be 17.5. This will be the one line. This is the first line and this is the second line. Okay, we are applying and we will select one more line here. We have to select means we have to change the along x direction. That means we are adding between 0.3 as a clear spacing. That means we'll select the spacing of 2.8. now the line has changed. 2.8 plus 3.5, that means 5, 6.3. The next line will be line on 6.3. 6.3, or you can defaultly check as 6.5 to the same. Okay, again applying. Again we'll do it at 15 meters distance also. And okay, now we selected 4 pass totally. 1, 2. Okay, he is came only 2. We'll select 3 more. That means at 2.5 with the left and right curve, width will be 3.5 same. We'll apply. You can observe here this blue line indicates now. Again we are giving, we have only option to select 2 lines because our acting line is only 2. We have to change means we'll give 6 meters with 90-degree orientation. Sorry, 6.5 will give for the second line. That will be the new section. Okay, this is the third section, this is the second section, and the orientation of 90 and length will be 25 and this will be lie at 15. The left and right curve we are applying and adding. We'll go for the fourth. Will same orientation will be 90 and the length will be 25 and the distance will be 20. We'll take at corner. Width will be same 3.5. This will be applied. Now check the lines from first fourth line is this is the first line at 20. X 20 means it will be the end, so we have to reduce 3.5 from the 20. That means 16.5 will be the line. 16.5, or else you can, this will be the applicable, and go to the second line, that means this line second, this is 15, so reduce to 12, and here you have to add both curves. Now go to the this third line, add just curve there, and okay, we have selected the 4 lines with between area. Now we will add load for the, we'll first select the vehicle. Our topmost vehicle is IRC AA Tracked Vehicle. This will be added, new vehicle 58. okay, we'll get directly give to IRC 58. Number of axials will be 3. okay, this will be added. okay, now go to the loading, in it select the influence surface generator. Here directly the performance will be placed. This is the advanced deck slab design. If you are well to design the advanced, then this mode you can use anywhere in the world. This process takes some time, but the result will be the accurate. okay, after designing the deck slab, the process takes slowly to solve, because we have taken the 4-way line. That means you can say is that 2-way 2-line route. With the length of the deck slab has 25 meters and the width of the deck slab is 20 meters. Now you can observe the influence diagram, that means loadings. Here we can see the nodal displacement for all decks from the node 1. You can observe that this area is little damaged. The highest force is occurring at this edge. This area can damage, or we can say this smaller portion can change your deflection area. This is the maximum deflection occurring at that plate. This is the shear force. Okay, you can see the influence diagram with the beam end forces. These are the beam end forces. Here the vehicle is acting IRC AA Tracked Vehicle. Okay, by this the deck design is completed. I hope you like this video. If you like the video, please subscribe my channel For your more information, please click on bell button. This is the deflection, how the deflection is going on. There is a less deflection, so it is not visible. What is our maximum deflection we got? That is minus 0.023. If you see the length to depth ratio, it is a negligible deflection. Thanks for watching.